Now we'll see greedy solution for this activity selection problem. So far we have seen dynamic programming solution and it was very difficult, correct? But we can solve this problem easily using greedy choice. So what is the greedy choice here? I will tell you. So in this problem there is a greedy choice. That's the reason we can solve this problem easily with respect to problems complexity, at the same time complexity also. We will see that. First, what is greedy choice here is, first sort the data using finishing times. Once it is done, then always pick up the activity whose finishing time is earliest. That is a strategy. Let me do that. Example, if I follow that one, what is the step? Only one step. Every time pick up the activity from the existing activities whose finishing time is earliest in the activities. Example, first time if you see, this is the activity whose finishing time is earliest, right? Then pick up A1. When I take it, its interval is what? 1 to 4. Then directly go right side. Why you should not go left side is, if you go left side, then that activity's finishing times will be less than 4. If and all if that kind of activities exist, we would have taken them before, correct? Then always go right side. Now start here, search for an activity who starts after 4. Why? If any activity starts before 4, then it may not be compatible with this activity A1. Already you took A1, then your next activity should start after 4. That's why don't take this one, it will not be compatible with A1, not compatible. This is the C, this activity starts after 4, that's why take it. And especially it is again, what is the strategy we are following always? We have to, there might be lot of such activities at right side. Example, this is also starting after 4, but whose finishing time is earliest? Always we have to pick up an activity whose finishing time is earliest. That's why I pick up this one. Then I add here A4 to the result. Then this time I will fetch the finishing time, which is 7. This time I immediately start here and search for 7. Where I have to search? Whose activity starts after 7. So see the starting timings. So start time here is, which is greater than 7. Take it and add to the list. This is A8. When you take A8, see the finishing time. It will be definitely earliest among all such activities. Take it. This time search for 11 immediately after 8. Then is there any activity which starts after 11? Yes, 11. Pick it up. Do you remember one thing? While doing this strategy, we are always going forward, correct? So we are not oscillating in the array. Remember that point. Now we'll see the time complexity. Definitely greedy choice will work. I will tell you the reason for that. Assume that, let's say, really greedy choice is working and it is giving optimum solution first. Then what is the time complexity? Now the time complexity, if you see, first of all we sorted the data. There are n activities. Then time complexity of sorting, we know that if you use merge sort or heap sort or anything, it takes n log n time, correct? Then after that, take a pointer and keep it first activity. That will be the first activity which is starting, whose finishing time is earliest. Take it, then fetch the finishing time and search for an activity whose starting time is after 4, but go right to left in that way. While searching, you will come somewhere and take that activity and fill here. Then again search here for the next activity. Again search the next activity here. Eventually what I am saying is, so your total program's running time is only order of n. The reason, we are simply scanning your array only one time, right? So always we are going like this. That's why the time complexity is order of n, correct? So when it will be more than n, example, always for every activity I took, let's say, one activity. After that again if I start from the scratch and again if I go up to end, then the time complexity will be order of n square, because you will be in the worst case doing that activity n times. But here what I am doing is, when I select an activity, so I travel for some point, correct? After that my search begins at right side, correct? I never come left again. That's why this at most you are traversing entire array, not more than that. That's why algorithm time complexity order of n, but for sorting the data n log n. Okay, now let me revise the solution. Take the first activity A1 and see the fetch the finishing time 4. This time started second activity, search for a value 4 in the start times. We stop here, see. So we are just searching the array, that's it. Now immediately fetch the second dimension, which is finishing time, which is 7. Now start at the next location and again search for 7 or greater than 7. We stop here in that way. So we are after all scanning the array, that's it, not more than that. That's why order of n. Did you remember? So dynamic programming solution was order of n cube. Now we got, since we have greedy choice, that's why greedy choice won't work for every problem. Don't say that, sir, I solve every problem using greedy technique. It won't work. Greedy technique can be applicable only if that problem itself has greedy choice. Otherwise we can't do. So that's why time complexity will be n log n plus order of n, which is far better than order of n cube. Now summary is, when any problem has greedy technique or greedy choice, then try to identify it and you solve it. Then you can solve it better than dynamic programming. Understand? So and the difference comes because dynamic programming was considering all possibilities, but greedy technique was only considering best choice. That means only one choice it was fixing, and it is hoping that it reaches to optimal solution. But in this problem it is reaching, but not always. Understand? Now we'll see why this greedy choice always gives optimal solution. So for that I take two solutions. One is my solution, second one let's say optimal solution. And I'm assuming that initially my solution, which is using greedy strategy, that means which is using greedy choice technique, is not optimal. Let's say first I assume it is not optimal, after that I prove that it is optimal. So this is, let's say, optimal solution. My solution is not optimal, but I know the activities in my solution, that is, one is a1, after that a2, after that let's say a3. And optimal solution has activities b1, b2, b3, b4. So definitely at least one more activity optimal solution should have, right? Then only it is optimal. If this also has 3, then we are same, then I can say that my solution also optimal, correct, with respect to number. Now let's say it has 4 activities, I have 3 activities. First of all I compare a1 versus b1. If they are same, then I compare a2 and b2. If they are same, then I compare a3 and b3. If they are same, if a1, a2, a3 equal to b1, b2, b3, then he picked b4, right? If he can pick b4, then I also can pick one more candidate, isn't it? Why? Example, a1's activity 2 to 10, a2's activity let's say 15 to 20, a3's activity something 25 to 30. See, all are compatible. Since b1, b2, b3 equal to a1, a2, a3, they will be 2 to 10, 15 to 20, 25 to 30. Now if b4 he can pick, then that's starting time should be after 30, maybe 31 to something, 50 or something. If he can pick it, then according to my greedy choice, after picking a3 whose finishing time is 30, I search for activities after 30. If he can get an activity, I also can get activity, because both are working on same set. That's why he is wrong. That means really he is getting before, I also get before, then my solution also optimal. Done. So second thing, maybe he has 4 activities, but before b4, let's say here there is a difference. I took a1, a2, a3, he took b1, b2, b3, b4, but not all are same. That means his activity is a1, my activity is a1, his activity b1, it matches, but a2 doesn't match. That is second possibility. First one, what we did, we thought a1, a2, a3 matches with b1, b2, b3, but in that case we proved that that is impossible. Second one, if a1 matches with b1, but a2 and b2, let's say first time they differ, then I ask, we'll see, if they differ, what are the time intervals? A1's time interval, if it is 2 to 10, b1 also 2 to 10. Then what should be b2's time interval? B2's time interval should be after 10, correct? Maybe 11 to 30 something. Then what about a2's interval? If it is, let's say, 15 to something 30, then both are, see, a2's time interval finishing time is 30, b2's finishing time is 30. Now did you remember, in greedy choice always we pick up an element whose finishing time is earliest, correct? So here, according to my greedy choice, if I, in the place of a2, I would have taken this one also. I had a possibility, correct? That means, so really I did not pick b2, means what? There are two choices for me at that time. One is a2's finishing time is 30, b2's finishing time 30. That's why I picked one thing. Instead of this one, I would have picked b2, correct? Not a problem for me. That means I was capable of doing that. Okay, let's say Not a problem. That is not a problem. Still, I am right. What if it is 11 to 35? Then, if this is the case, your finishing time is 30, B2's finishing time is. Now we'll see why greedy choice definitely leads to optimal solution. Let's take two methods. One is greedy method. Second one, another method. I don't know what is that method. Greedy method is my method, and another method is, let's say, optimal method. That means it is giving optimal solution. Assume that, let's say, your greedy method is not giving optimal solution, but I prove that greedy method always gives optimal solution. Okay, first of all, list out all the activities in your greedy method. They are, let's say, A1 something, A2, A3. So here optimal solution should contain at least one extra activity, that is, let's say, B1, B2, B3, B4. Otherwise, if they are same, then my greedy method also gives, I can say that, optimal solution. Now at least one activity should be more than our greedy method. Now I ask first question, A1 and B1, are they same? If A1 and B1 are same, then no problem, right? Because both are having same idea. Then I compare A2 activity B2. If they are same, then I compare A3 and B3. If that is also same, then I ask, how did you pick B4? Then he says, after B3, B4 was compatible with B1, B2, B3, I picked it. Then let's see the values, then you understand. Example, B1 is 10 to 20, B2 20 to 30, B3 30 to 40, then B4 is compatible with them, then it should be 40 to something. If you have an activity which starts after 40, then even that I can pick here. My greedy method also picks it, correct? Because we know the algorithm, just execute, you understand. Now, so that is not the case. Then maybe B4 is from 5 to 10. It is left side of B1. Then if we have this kind of activity, then why I will pick A1 which is starting at 10? Because always I pick up, did you remember one thing? Strategy is picking up the activity whose finishing time is earliest. I thought A1's finishing time is earliest among all. That's why I picked it. Really we have this kind of activity, I would have taken it, correct? So that's why it is impossible. Then, so B4 kind of activity impossible, then remove B4, then optimal solution and your solution are same, right? Now, we will see the second case where you are not matching A1, A2, A3 with B1, B2, B3. That means these activities are not matching with B1, B2, B3. Example, A1 you have, he has B1, optimal solution has, both are same, but B2 is different from A2. That means after some time in the activity list, one activity is differing first time. Then I ask, if A1 equal to B1, example A1's duration is 5 to 10, B1's duration also 5 to 10. Now I ask B2, Mr. B2, you are not, you are different from A2, then why? What is your finishing time? My A2's finishing time is, let's say, 10 to 20, that means 20. Then B2's finishing time, let's say, either there are two cases. Maybe it is, one case is something 10 to 30 or something. That means finishing time is more than A2's finishing time. If B2's finishing time is more than A2's finishing time, that's why, that is the reason I did not pick it, correct? Let's take that case. That means B2 is starting at 10, but it is finishing at 30. Then I will tell you one thing. Simply remove my A2, simply remove B2 from this optimal solution and add my A2. So that is also starting at 10 and but finishing at 20. Then you will get some gap, right? So probably you may get one more element here. That means what I want to say is I am converting by removing, already B1 is A1. So remove this B2 and write A2. Because of that you get some gap and you might get more activities into it, correct or not? So that's why in that way my solution is still better than this optimal solution, correct? And one more thing, I removed activity of this optimal solution and I replaced with one activity of my greedy method. So because of that I did not lose the number of activities in this optimal solution. The count is same, correct? So in that way finally what I am proving is I am slowly converting your optimal solutions activities I am replacing with my greedy methods activities. So in that way, correct? So initially I had A1, now optimal solution also has A1. After that we have A2, then optimal solution had B2, but we proved that B2 should be either A2, otherwise it is not better than A2, correct? So that's why we converted it to A2 and we got some space. If you, in the place of A2, if we had B2 in optimal solution, it is definitely inefficient. The reason, our finishing time, A2's finishing time was earliest, then if I take it, I can have this space and I can utilize that and I can have more activities, right? In that way, so definitely easily we can see that greedy method leads to optimal solution. Okay.